Hi, my name is Molly Vick, and this is my second lab report for Physics 2212. Today we will focus on the line of charge experiment. This is an extension of Lab 1 about charge tapes. So now I will give you an overview of my lab. I'll start by giving an introduction of the lab setup using the fundamental principles. Next, I'll show you my GlowScript model and code and the program's output. Third, I'll show you the results and the values I calculated for the magnitude of the change on tape and the magnitude of the electric and gravitational forces on tape. I'll go over the assumptions and discuss the discussion questions. So here are the fundamental principles used for this lab as well as their formulas. We use Coulomb's law, the electric field of point charges equation, the electric field of a rod, the force due to gravity, the relationship between force and electric field, and superposition, which says that you can use vector addition to add the electric fields, but the charges do not affect each other. So here are my measurements and my setup. So this is the distance that I got, the mass, length, width of tape B, as well as a picture of the setup of the lab where we floated tape B by holding tape A below it. So here are the calculations that I did and used in my GlowScript code to find Q. So I set the magnitudes of the gravitational and electric forces equal to each other. I used the formula of the electric field of a rod and calculated Q that way. So I got 9.242 by 10 to the negative 9th coulombs. Okay, so here is a piece of my GlowScript code. I've defined a function to calculate the electric field due to an observation location and specified charge. And so here is the code that shows the line charge portion of the lab. I split up the tape into multiple point charges, and then I found the electric field of the top charge and bottom charge and added all the charges together to get the net electric field. Okay, so here is the code that shows the line charge portion of the lab. I split up the tape into multiple point charges, and then I found the electric field of the top charge and bottom charge and added all the charges together to get the net electric field. So now we'll look at the output of the code. So the green arrows show the net electric fields for each point charge, and looking at the output we can see it gives us the magnitude of both the electric and gravitational force. So some assumptions about the lab. So for the first one, ignore air resistance on a moving object. We can ignore this completely because the object is static and is not moving. The second one is also no because we treated each tape as a line charge instead of a point charge and no charge on the tape. And thirdly, we can assume that the last one is yes because we assume the charges of the two tapes were the same when we did the lab. Okay, so this formula and solving over here is how I found the magnitude of a point charge based on lab 1, and so the magnitude is shown there comparing lab 1 and lab 2 results. So looking at these discussion questions, for the what if question, clearly the distributed charge model, what we did in this lab is significantly larger than the one of the point charge that we calculated. So you can see that if the model is a point charge, you get 1.857 times 10 to the negative 9 coulombs, and for lab 2, this model gave us 9.242 times 10 to the negative 9 coulombs. And so why do these differ? These differ because of the approach we took to get them, and the value that is closer to the real value is lab 2, which is the distributed charge model. This value is what we would consider closer to the result. Thank you for listening, and I hope you have a great rest of your day.